Let's talk about the fundamental theorem of calculus, and sometimes it's called the first fundamental theorem of calculus. Leibniz and Newton discovered independently and about the same time that differentiation and integration are inverse relationships, where with differentiation we started with the secant line, found the slope of the secant line, and through the limiting process found the slope at a tangent. In integration, we start with a general curve and then we approximate at areas with delta x, delta y, and then we were able to find the actual area under the curve. So differential calculus is finding slopes of lines. Integral calculus is finding areas under curves. The fundamental theorem of calculus brings together some very interesting concepts. Suppose I have a function f, so this is my function f, that is continuous on a closed interval. Remember, if it's continuous, that means it's integrable. Doesn't mean we can find the integral, and suppose we are looking at this from a to b. Then this integral from a to b of f of x dx is going to be the antiderivative of f evaluated at b minus the antiderivative of f evaluated at a. Now, here are some guidelines. If you can find the antiderivative, and sometimes you can't, we have a way to evaluate it without having to use the limit of a sum. So all of that we did with antiderivatives is going to come in very handy. Now, to apply it, this is the notation we use. We use the integral from a to b of f of x dx is equal to the antiderivative, and this says evaluate it at a to b. And you always have to write this right here. I tend to write a straight line, okay, instead of the brackets. And then this is f, well, this is f of x. This is f evaluated at b minus f evaluated at a. It's always top minus bottom. Remember that. Top minus bottom. Now, for this, you do not have to include the constant of integration, because if you suppose you had f of x plus c evaluated at a to b, if you did the first term so that it's f of b plus c minus f evaluated a plus c, we can see these two constants are going to cancel out. So let's look at a couple. If I want the integral from a to b of x squared minus 3x, now we already know that we can break this up so that this is equal to the integral from 1 to 2 of x squared dx minus 3 times the integral from 1 to 2 of dx. And we can do these separately. The integral, the antiderivative of x squared is x cubed over 3. And we're going to evaluate that at 1 and 2 minus 3 times the integral from 1 to 2 of dx is just x. Evaluate it at 1 and 2. Now I'm going to do these separately. This is 1/3 times. Now I'm going to factor that 1/3 out. So this is 2 cubed minus 1 cubed. That's my first one. Minus 3 times 2 minus 1. I recommend you factor the constants out so you don't get lost. So this is 1/3 times 8 minus 1 minus 3 times 1. So this is 7/3 minus 3. Get a common denominator. 7 minus 9 over 3 is minus 2/3. Now let's look at this one. This is 3 times the integral from 1 to 4 of x to the 1/2 dx. So this is 3 times the antiderivative of x to the 1/2 is x to the 3/2 divided by 3/2. Evaluate it at 1 and 2. Let me combine these constants here. This becomes 2. times 2, or excuse me, 1 and 4. Don't change your limits of integration because that's a bad thing to do. I do it sometimes. So this is 4. So this is 2 times 4 to the 3 halves minus 1 to the 3 halves. Now what I recommend is you do the square root on this first. So the square root of 4 is 2. 2 cubed is 8 minus 1. So 8 minus 1 is 7. So this is 14.